The objective of this section is to apply pigeonhole principle to a second type of example. Here's another type of question you may encounter. That is, to find the number to pick to ensure a certain result or criteria to meet. Let's read the question together. A drawer contains 6 black and 6 white socks. You reach in and pull some out without looking at them. What is the least number of socks you must pull out to ensure that you get a matching pair? Our objective here is to get a matching pair. So it could possibly be that the first sock I pick is black and the second sock I pick is also black, in which case I got my matching pair. It could also be that the first sock I pick is white and the second sock I pick is also white, in which case I also get a matching pair. But is that the worst case that can happen to me? No, the worst case is if the first sock is of one color, say black, and the second sock is of another color, say white. That means I still don't get a matching pair yet. What will happen to the third sock? If it turns out to be black, then I have a black matching pair. If it turns out to be white, then I have a white matching pair. Either way, 3 socks is the least number of socks that will meet my criteria, even if the worst case happens. So that becomes my pigeon. And the pigeonholes will therefore be the number of socks just before I meet my criteria, which is 2 socks in this case. How do we explain? Just state that in the worst case scenario, if the first 2 socks are of different colors, then the next sock will guarantee 1 matching pair. So the answer is 2 plus 1 socks, which is 3. Therefore, by pigeonhole principle, since the number of pigeons are more than the number of pigeonholes, in this case 3 is more than 2, therefore 3 socks will ensure that at least 2 socks share the same color or 1 matching pair. In this example, we need to find the minimum number of English words to guarantee that at least 2 of the English words share the same beginning letter. So who is the pigeon and who is the pigeonhole? The word same will tell us that the one that will be shared is the letter. So letter is the pigeonhole, which we do have 26 possible letters in the English alphabet, namely A to Z. And the English words are the pigeons, which we are supposed to find the minimum number required. The next thing to consider is, what is the worst case scenario? Well, suppose that the first word begins with A, and the second word begins with B, and the third word begins with C, etc., etc., until we get to the 26th word, which begins with Z. So we have 26 English words, which begins with 26 different letters. Now what will happen to the 27th word? Well, then the 27th word will need to share the same beginning letter with one of the earlier words. Therefore, we need to select 26 plus 1, or 27 words, in order to meet our criteria. Hence, by pigeonhole principle, since the number of pigeons are more than the number of pigeonholes, in this case, 27 is more than 26. Therefore, selecting a minimum of 27 words will guarantee that at least 2 English words share the same beginning letter. In this example, what is the least number of integers between 1 to 10 you have to select to guarantee that you have at least one integer that is divisible by 3? To answer this question, first we need to realize that there are 10 integers between 1 to 10. Out of these 10 integers, only 3, 6, and 9 are divisible by 3. The rest are not. So only 3 integers are divisible by 3, while the other 7 are not. So what's the worst case scenario? Our objective here is to get an integer that is divisible by 3. It could possibly be that the first number I picked is already divisible by 3. But that won't be the worst case scenario. The worst case scenario would be to pick all the 7 numbers that are not divisible by 3 first. Then the next one we pick will definitely have to be divisible by 3. Hence, selecting 7 plus 1, or 8 integers, will meet our criteria. So that becomes our pigeons. And the pigeonhole will therefore be the number of integers just before we meet the criteria, which is 7. Therefore, by pigeonhole principle, since the number of pigeons are more than the number of pigeonholes, in this case 8 is more than 7, therefore 8 integers will guarantee at least one that is divisible by 3. In summary, the pigeonhole principle states that if n pigeons fly into m pigeonholes and n is greater than m, then at least one hole must contain 2 or more pigeons. When answering questions on pigeonhole principle, you may consider the following. First, identify the pigeons and the pigeonholes. Depending on the type of question, the pigeonhole could simply be the attribute that is to be shared. Sometimes it could also be that the pigeon is the least number that is needed to meet a certain criteria, while the pigeonhole is the number just before we meet that criteria. Next, explain the worst case scenario. What is the longest route to take before you meet a criteria? Therefore, how many pigeons and how many pigeonholes do you need? Your explanation need not be lengthy, but you can use the diagram above to help you illustrate your point. Finally, decide if you can use the pigeonhole principle to make a conclusion. A typical conclusion would be something like, since the number of pigeons are more than the number of pigeonholes, therefore, have I or have I not met the criteria or objective which I set out to achieve?